So we are still in Unit 11 on trigonometry. We're doing Lesson 10, which is on reciprocal trig functions. There's 3 more trig functions that you have to learn, but you'll find if you know the first 3, the next 3 will be pretty straightforward. So these are the 3 inverse trig functions. So it's secant, cosecant, and cotangent. The secant is the reciprocal of the cosine. So I'm just going to put R for reciprocal of the cosine. Now the way that you would find that is you would just find the cosine and you would do 1 over the cosine. I'm actually going to show you a quicker way. You're just going to flip the cosine upside down, really. The cosecant is the reciprocal of the sine. So they have denoted it 1 over the sine, which again, we're just going to flip the sign upside down, okay? And the cotangent is the reciprocal of the tangent, which would be the tangent flipped upside down. But a quicker way, and you'll see when we do this, to find the tangent, you have to find the sine over the cosine. So really to find the cotangent, you're flipping it upside down, you're finding the cosine over the sine. Now I want to point out a couple of things. So how each thing is denoted. The secant of whatever angle, in this instance it is theta, is SEC for secant, the first 3 letters, which makes sense. The cosecant is CSC. The C stands for co, and the SC is the letters in secant. Okay. And then the cotangent is COT. Now, as far as memorizing these, tangent and cotangent go hand in hand. That makes sense. The secant and the cosecant are it's almost like the opposite of what you would think. You would think that the cosecant would go with the cosine, but it doesn't, okay? So the secant goes with the cosine, and the cosecant goes with the sine. Basically, if you can remember that the S and the C is a pair, C and an S are a pair, right? As far as the first letters are concerned, the 2 S's don't go together and the 2 C's don't go together. So really, once you have that figured out, this is the same thing that we did in the last lesson and one of the earlier lessons in the unit. So what you do need to have handy or memorized or whatever are your coordinates of your angles. So your 30-degree angles, I'm not going to write them all. You should write them down if you don't have them memorized, but your 30-degree angles are the square root of 3 over 2 and 1/2. Change your signs depending on what quadrant you're in. Your 60s are just the opposite of that. So 1/2 square root of 3 over 2. And then your 45s, square root of 2 over 2, square root of 2 over 2. All right, so shall we do some examples? We shall. So we're going to find the secant of 60 degrees. So the secant is the opposite of the cosine, or the reciprocal of the cosine, okay? So I'm going to find the cosine of 60 degrees. So 60-degree angle, and the cosine would be the x value. So the cosine of 60 degrees is 1/2. Now keep in mind, we're in quadrant 1, and we're talking about our x value. So anything in quadrant 1 is positive. So that is something that you do have to pay attention to also throughout this whole thing. So now I'm going to take the secant of that. So all I'm doing is I'm flipping it upside down, and it is going to become 2 over 1, or just 2. Now, I'm just going to show this to you once for those of you who want to know. What I just showed you is the quickest way to do it. The definition, though, says that the secant of 60 degrees is equal to 1 over the cosine, right? So 1 over the cosine of 60 degrees. So that would be 1 over, and then we figured out the cosine was a positive 1/2, right? So then I'm going to do 1 divided by 1/2. And then the rule for division, or you could do it on your calculator, but the rule for division is keep, change, flip. So I get 2 over 1, which is 2. So that's really what's going on mathematically. But as you can see, I got the same answer, so it's easier just to flip the original trig function upside down. All right, so now we have to find the cotangent of 150 degrees. Well, the reciprocal of the tangent of 150 degrees is the cotangent, okay? So as a little reminder from our last lesson, it is sine over the cosine, okay? So 150 degrees is a 30-degree angle. So the sine or the y value is 1/2. The cosine or the x value is a square root of 3 over 2. However, we are in quadrant 2, which means my x value is negative or my cosine is negative. Remember when we simplified that, we just took our two numerators and did 1 over the square root of 3, make it negative, okay? That's the tangent. So I want the cotangent, so I'm just going to flip that upside down to the square root of 3, the negative square root of 3 over 1, and it just stays like that. Now, what you could have done in the beginning if you wanted to, this is a little bit easier to recognize with tangent. You could have flipped this to cosine over the sine in the beginning, and you would have gotten the negative square root of 3 over 1. It's the same idea.
Exercise 3 is asking for the cosecant of 3 pi over 2. Now, that is in radians. I need to convert it to degrees. So that's when we multiply it by 180 over pi. Those cancel. You do 3 times 180 divide by 4, and you should get 135. So we're finding the cosecant of 135 degrees. So the cosecant is the reciprocal of the sine. So I want to find the sine of 135 degrees. So 135 degrees is a 45-degree angle. So it's going to be the square root of 2 over 2. It is the y value in quadrant 2, so it's positive, right? So now all I have to do is flip that upside down, and we get 2 over the square root of 2. And that is that. It's not so bad, really. You just have to memorize what name goes with the original trig function and just flip it upside down. Exercise 2 says, which of the following is the closest to the value of the secant of 52 degrees? Now notice 52 degrees is not on our list of angles we have to memorize, and if you look at your answers, obviously it's not, those are not numbers that we are supposed to know. So what you're going to do in your calculator is you're going to do, I would do alpha y equals and do a fraction and do 1 over the cosine of 52 degrees. Make sure your mode on your calculator is in degrees. If not, you're going to get something weird. I think you get like a negative. Okay, so once you do that, you should get 1.62. Now, you may be wondering, can you just plug these into your calculator? You can if you do it the way that I just showed you with 1 divided by. If you look at your calculator above the sine, cosine, and tangent, you will see something that looks like sine to the power of -1, and same thing for cosine and tangent. Those are inverse trig functions. They're not reciprocals. There is a difference. You may remember doing this last year in geometry, but it is not the same. Even if you try to do it, it's not going to work. You're going to get an error. So the only way to do it is to put it in as a fraction like that, okay? Because secant, cosecant, and cotangent have variable denominators, there are angles which make these denominators equal to 0, making the function undefined. We talked about this a little bit in the last lesson. Which of the following values of x is not in the domain of y equals the cosecant of x and y? Okay, so basically by them saying what's not in the domain is asking what is going to make the denominator 0. Now, the cosecant is the reciprocal function for the sine of x. Okay? So what we're going to do is we're going to find the sine of x for each choice and then flip it upside down, okay? So I can tell right away that it's not going to be 2 or 4. Can you tell why it's not going to be those two? Because even if you don't know off the top of your head what they are, those are 2 angles that we were supposed to memorize, right? On our 30, 60, and 45 list, right? None of those have 0 anywhere in any coordinate that you're supposed to memorize. So even if you flip it upside down, there's no 0 to flip it to or from. So these 2 are gone. I know that the answer is always going to be something that lands on one of the axes because that's the only time a coordinate is actually 0. So at 90 degrees, our coordinate here is 0, 1. And at 180, our coordinate here is -1, 0, right? So the sine of 90 degrees is 1 over, well, it's just 1, right? But if I need to put it over something, I'm going to put it over 1. So I can flip it and get 1 over 1 or 1, right? So the cosecant of 90 degrees is also 1. All right? So now let's do the sine of 180 degrees. So the sine there, or the y value there, is 0. And I'm going to put it over 1 if I need to be a fraction. Any number, you put it over 1, it's still equal to itself, right? 0 divided by 1 is still 0. So if I'm going to find the cosecant of 180 degrees, I'm going to flip that upside down and I have 1 over 0. Therefore, the denominator is 0. That is not possible. So we are saying choice 1 is the correct answer. Okay, exercise 4 on the next page has determined the sign of the following trig functions in the quadrant given. Part A says the cotangent of beta for beta in quadrant 2. Okay, so we don't even have the angle. We don't even need to worry about what the coordinate is, all right? So the only thing that we know is that we are in quadrant 2, and we're being asked to figure out if the cotangent is going to be positive or negative, right? Well, the tangent is the sine over the cosine. I'm just going to skip that part and do the cotangent, which is the cosine over the sine. Now, in quadrant 2, my x value is negative, so my cosine is negative, but my y value is positive. Well, a negative divided by a positive is a negative, so it's a negative. Part B says the secant of beta for beta in quadrant 4. So here we are. We're in quadrant 4. The secant is the reciprocal for the cosine, right? So it's 1 over the cosine. So what is the cosine of beta? Well, that's the x value, and the x value is a positive. So we would always put that over 1, which is going to be positive. We're going to flip it. Well, a positive divided by a positive is a positive, so it's just a positive. Part C is the cosecant of beta for beta in quadrant 3. The 3 has been wrapped over. So we are in quadrant 3. Really everything's negative here, but we're still going to talk about it. So the cosecant is the reciprocal for the sine, right? So what is the sine? Well, it's going to be negative. The y value is negative, right? I put that over 1, which is a positive. I flip that, and negative divided by positive is a negative. So I'm not sure if you noticed or not, but the sine is staying exactly the same as the original trig function. So that is nice, really, so you just have to think a little bit less. Okay, exercise 5. These always kind of stump me a little bit because of the way that they're worded, right? It says if the cotangent is less than 0 and the secant is greater than 0, then theta could be which of the following angles? Y. I love how they ask y when it's multiple choice. Okay, so if they're saying that the cotangent is less than 0, that means that the cotangent is simply negative. Okay, now they're saying the secant is greater than 0. So the secant is positive. Okay, so I'm going to focus on the secant being positive first because the cotangent being negative has a couple of more variables there. So the secant is 1 over the cosine, right? So 1 is positive. So the cosine has to be positive, okay? In order for when you divide those, you get a positive, okay? So what quadrant is the cosine or the x values positive? Well, quadrant 1 or quadrant 4. Okay, so those are the only two choices. So when I go and look at my choices, choice 3 is in quadrant 2, so that is gone. And choice 4 is in quadrant 3, so that is gone. Okay, now the cotangent is the cosine. I'm flipping it over. I'm not doing 1 over the tangent because then I have to do sine over cosine and then flip it. So I'm just going to flip it to begin with. That's the only one that I like to flip immediately. So it's going to be the cosine over the sine, right? Tangent is sine over cosine. I'm doing the cotangent, which is the reciprocal, cosine over sine. I need it to be negative. I already know that my cosine is positive. So the only way I can get a negative answer is for my sine to be negative. Now, what quadrant is my sine going, or my y value going to be negative? Quadrant 4, because in quadrant 1, everything is positive. So between choice 1 and 2, which one is in quadrant 4? And it is choice 2. We should be able to produce all 6 of the trigonometric ratios if we are given 2 sides of a right triangle. This is a very popular question where you have to find all 6 trig functions, okay? A right triangle is shown below with the sides of lengths A and B. Find the length of the hypotenuse. Okay, for the sake of this being new, I'm going to change the length of the sides. Using a small a and a small b, when your angles are a capital A, B, and C. I find that confusing. I'm going to use numbers actually, okay? So I'm going to cross these off and we're going to use numbers. So this side right here is now going to be 5. This side is going to be 12. Now you might already know the third side, but because in the past lesson or so I've skipped finding it, I am going to do it. So this is the hypotenuse, it's C. So I'm using the Pythagorean theorem, a squared plus b squared equals c squared. So I have 5 squared plus 12 squared. And a little reminder, the a and the b, I mean, it's labeled a and b, but if you did 12 squared plus 5 squared, you'd get the same answer. So I have 25 plus 144 equals c squared. When I add those together, I get 169 equals c squared. So my c is almost alone, not quite yet. I'm going to take the square root because the square root cancels a square. And the square root of 69, it's plus or minus 13, but because this is a triangle, it's real distance, we're just going to use the positive 13. Some of you might have already recognized that that is a special right triangle, 5, 12, 13. If you already knew that, you didn't have to do all that work. Okay, so when I look at part B, it says state the value of each of the following trigonometric ratios in terms of I'm just going to change this. I'm going to cross this off because we're not finding in terms of A and B. Okay, so we're just finding each trig ratio. Okay, if I look at all my choices there, it looks like I'm finding sine, cosine, tangent, cosecant, secant, and cotangent, all of angle A. So I'm going to highlight angle A just as a reminder that this is what we're using. Now, I think we're also going to need to use SOHCAHTOA. Okay, so if I'm finding the sine of A, I need the opposite over the hypotenuse. The opposite is the one that doesn't touch the angle. So in this case, that would be 5. And my hypotenuse is 13. What I like to do before I even try to do the cosine or the tangent is I like to do the reciprocal function right away because all I have to do is flip it upside down. And they do have them lined up nicely for you here. The cosecant of angle A would be the reciprocal of the sine of A. So it's 13 over 5. Bam, 2 are done already. Now let's do the cosine. So the cosine is the adjacent over the hypotenuse. So that's going to be 12 over 13. And I'm going to flip that for the secant because that's the reciprocal. So I have 13 over 12. Now the tangent is opposite over adjacent. So that gives me 5 over 12. And the cotangent is just the reciprocal of that. So 12 over 5. Not so bad, huh? Okay, number 7 says, and I don't know why it's all squished like that. I don't know why this happens whenever I convert it to a PDF, but if alpha is an angle whose terminal ray lies in quadrant 4, I'm just going to highlight that quickly because I'm sure that's important, and the cosine of alpha is 1/3, then determine the exact value of the cosecant of alpha. Show your work. All right, there's 2 ways to do this. You can sketch a graph, quadrant 4, do your right angle, and use SOHCAHTOA. Since we sort of just did that, I'm going to do it the other way, where I use the Pythagorean identity. Now, before we get started, I mean, they give me the cosine. Is the cosecant the reciprocal of that? No. The cosecant is the reciprocal of sine. So I do need to find the sine. So that's why I'm going to use the trig identity. So a little refresher, the trig identity is the cosine of alpha squared plus the sine of alpha squared equals 1. So I'm going to plug in my cosine of 1/3, square it. The sine is the unknown, okay? So 1/3 squared, remember each of those gets squared, so it's 1/9. Now I'm going to subtract the 1/9 from both sides, and I get the sine, I should be squaring that, of alpha squared equals 8/9. Now, the sine is not alone, it's squared, so I have to take the square root of that. So the sine of alpha equals. Now you can take the square root of each of those separately. So you have the square root of 8, that's not perfect, I'm going to leave it like that for now, over 3 because the square root of 9 is 3. So just keep in mind we're in quadrant 4. So is the sign going to be positive or negative? Is my y value in quadrant 4 positive or negative? Well, it's negative, so I need to throw a negative in there. So now the reciprocal of that for the cosecant, I'm just going to flip it upside down. So I have 3 over the negative square root of 8. If you want to get fancy, the square root of 8 simplified is 2 rad 2. Okay,